Hello everyone, welcome back to my channel. Today let's go over a medium sliding window question that I just solved on my own. So I'm really happy about this. It took me quite a bit of trial and error, but I finally did it after trying for like 8 months. So again, I'm really happy. Let me show you my own solution. So basically you have a circle of red and blue tiles. They want you to find k contiguous tiles. So we already know we have a sliding window size k. And basically there's a weird circular nature to this, and let's first try to get all the windows of size k. So minus k plus 1, and then the subarray is just colors of I plus k. And let's print the subarray. So you get size 3 here. Now for these groups, you want to make sure that from everything is alternating, meaning from, let's say the subarray is 1, 2, 3, 4. From this index to this index, we compare the left and the right because the first and the last, except the first and the last one, has a different color, so the first and the last one don't count. So what we actually have to do is append colors of up to k minus 1. And again, I came through this through trial and error. And we want to extend that because there's a weird circular nature to this. And now what we can do is say flag is true, and we just want to compare the left and the right for every index from the first index up to the last minus 1. So for I in range 1, length of subarray minus 1. If there's any mismatch, meaning it's equal to the left or the current is equal to the right, then we set the flag to false and we break, because if the flag is still true, then it doesn't violate any of these conditions. It's all alternating from the, let's say we have this, then we want to compare the left and the right are all different. 0 and 0 are different from 1. And then we have an answer that we want to increment. And then at the end, we can just return our answer. So this is obviously n squared, and it's going to be really slow, as you'll see. So now we have to figure out how to optimize this, which basically just means, okay, so now we have this array and we want to figure out the left and the right, whether they're different or the same, right? So why don't we just let's just pre-compute the results. So let's say before, we know the first one is always good because the first doesn't even count because there is no left, and this one doesn't have a right, it's circular, so they count as good. And then at the end, we're going to append another good for the last one. And then we're going to go from I in range 1 to length of colors minus 1. And now this actually counts, right? So from this, left and right, are they both different? If so, good. If even one of them is the same from the left or the right side, then we append bad. So if colors of I is equal to colors of I minus 1, or it's equal to the right side, then we append bad. Otherwise, no violations, we append good. And now what we're going to do is use that in this thing. So print before of I to I plus k, and again we want 1 to n of 1, so I plus 1 to I plus k minus 1. So now what you'll notice is that we don't want a bad to appear anywhere, right? So all the subarrays that don't have bads in them means that we can say that this is good, right? So this is good, this is good, so the answer is 2. Just check our work. There's every single one has at least one B, so that's bad. So now we can just say if B is not in this, because we're just taking care of that, this rule right here, right? So each subarray we have to look like this as well, and also the original array. That's what we did up here to prepend it. And then answer plus equal to 1 if that's not the case. So then we submit it. This simplifies things a little bit, but this is still n by itself. We don't even need this. So since this is a fixed size sliding window, we just want to figure out whether B is in this or not. We can use a hash map to reflect the frequencies of this, right? So let's actually print I plus 1, I plus k minus 1. What this is going to tell us is we're looking for 1 to 3, 2 to 4, 3 to 5. So, okay, so why don't we create a counter like this and just shift it right by 1 every single time, right? So C is counter of before of up to k minus 1. Let's print C. That should reflect this. Since we want 1 to 3, so 0 to 2, so yeah, okay, so let's print before. Okay, cool. So now 0 to 2 is 2 G's and 1 B. Cool. And now what we can do, and this is the tricky part, but what we do is, how do we slide the window 1 to the right and reflect the changes? Well, first of all, we have to get rid of the current element, which is just going to be C before of I minus equal to 1. If C of before I is equal to 0, then delete it from the hash map because the 0 frequency, we don't care about that. And then here, after we do this, then we want to add it. So again, this just, I trial and errored my way to this. I plus k minus 1 plus equal to 1. And how you check your work is just print C and print before of I plus 1, I plus k minus 1. Once you get the formula down, it's really just a matter of optimizing it. So just make sure these line up. They don't line up now. So looks like the hash map is still off by 1. BG, nope. Okay, so GGG, BB. Nope, that's not right because this is just B. So why don't we actually print it here right after, before we, so in between, it's like a sandwich. In between we do the increment and the decrement. No, that's not right. So this is always consistent, but we gotta make sure the dictionary reflects the frequency changes because we're just making one change, expanding the window, adding one to the right, and deleting one from the left. So let's see here. This is out of range. So let's print C. GGG, BB, that's still not correct. Could it this be this? Nope. So if K is 3 and our window is then we know that the window is 1 to 2, so 0 to 1 first. So 0 to 1. Let's make sure we're starting at the right place. And print before, we don't care about. So 0 to 1, okay, we're starting at the right place now because this is reflecting in the beginning, but now 1 to 2. Okay, cool. So now you see that the dictionary reflects exactly what's in this. So that's what we want. Let's check here. So this, okay, that's good. That's good. That's good. Okay, cool. So now that makes our job a lot easier because we can just say if not C of B, then answer plus equal to 1, and we don't even have to go through all this hassle again, right? That makes it O of 1 now. Did I do this incorrectly again? Let's not worry about this. That looks correct to me. 2, 2. So 2, 2, 2, 2, 3, 1, 4. That looks fine to me. Right, so we're putting the counter, that's correct. So if, oh, we're doing it twice. Okay. Okay, cool. So now that's O of 1, right? So as we get rid of the print statements, again, we're just using a fixed size sliding window, adding one to the right, removing one to the left. You might have to play around with the conditions a little bit, but this is what I came up with on my own. So, and there you go, passes all test cases. Again, it's not the most efficient, but I did grind my teeth through this and come up with an answer. It's not the prettiest, but I'm proud of it. So that's it for this video. Hopefully it wasn't too bad. Thank you for watching and stay tuned for more.